In this chapter, we will explain the topics direction angles, direction cosines, and direction ratios. In two-dimensional analytic geometry, you learned about the direction of a line. A line in the xy plane through the origin has a direction angle alpha, which is the angle between the line and the positive direction of the x-axis. The tangent of the angle alpha, that is tan alpha, is the gradient of the line and is given the letter symbol m. There is also the angle between the line and the y-axis. It is angle beta. Alpha and beta are the direction angles of the line. Their cosines are direction cosines, and cos squared alpha plus cos squared beta equals 1. In three-dimensional geometry, the line can be outside the xy plane and anywhere in space. We now rotate the axes to the standard mathematics orientation. There is one more angle to consider. The angle between the line and the z-axis. It is angle gamma. The three angles are called direction angles. The cosines of the three angles, cos alpha, cos beta, and cos gamma, are called direction cosines. It is common practice to name the cosines L, M, and N, such that L equals cos alpha, M equals cos beta, and N equals cos gamma. Consider the line segment OP. It has direction angles alpha, beta, and gamma. Point A is located on line OP and 1 unit from the origin. From point A, draw lines perpendicular to the three axes. The projections of line OA on the x, y, and z axes are A, B, and C respectively. Since OA is 1 unit, OA squared is equal to 1. From the distance formula we proved in an earlier chapter, OA squared is equal to A squared plus B squared plus C squared. Therefore, A squared plus B squared plus C squared is equal to 1. Cos alpha is equal to A over 1 since OA is 1 unit, which means cos alpha is equal to A. In a similar way, cos beta is equal to B, and cos gamma is equal to C. Substitute for A, B, and C their values, cos alpha, cos beta, and cos gamma. Therefore, cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. In addition to direction angles and direction cosines, there are direction ratios, also called direction numbers. Consider a line segment OP with direction angles alpha, beta, and gamma. O is the origin of a three-dimensional coordinate axis. Let point A be on line segment OP and is at a distance d from the origin. The coordinates of point A are E, F, and G. Then we have cos alpha equals E over D, cos beta equals F over D, and cos gamma equals G over D. We can now write E equals D cos alpha, F equals D cos beta, and C equals D cos gamma. We replace cos alpha, cos beta, and cos gamma with L, M, and N. Since D remains constant as P moves, E, F and G are proportional to the direction cosines, and we can write E to F to G is equal to L to M to N. E, F and G are called direction ratios or direction numbers of line OP.